Hello, this is KHURRAM Nasir and you're watching Optometry with KHURRAM, and in the past video we have discussed about the Prentice Rule. Prentice Rule was about the spherical lenses, right? That how can we decenter the minus spherical lens, how can we decenter the plus spherical lens to induce prismatic effect, right? But in this video we are going to learn about that how can we decenter a toric lens or the cylindrical lenses. Why and how we can apply the Prentice Rule on the cylindrical lenses, right? So you know very well that the formula of the Prentice Rule is P is equal to H cross D, and in this formula P is actually representing that what is the prismatic effect actually, right? And H is actually representing the decentration, right? And D is actually representing the dioptric value of the lens, right? So for example, you got a card, you received a card from your customer, and the spherical lens on that prescription card is +6 spherical with +2 cylinder at 90 degree. This is the prescription, and a note is written on the prescription card as well, and that note is 5 prism base in, right? 5 prism base in. Now we will learn that how can we decenter this lens having spherical correction of +6, cylindrical correction +2 and axis 90 degree. How can we decenter this lens to induce this 5 prism of prismatic effect, right? So for example, first, if you have any prescription like that having cylindrical power in the prescription, first of all you will make a optical cross, and now we will learn that how we can draw an optical cross of this prescription. You know the spherical correction is +6, so you know very well that spherical mean that spherical value is on the every corner of the lens. The +6 power is at 360 degree of the lens. For example, if this is the spherical lens, it means that the plus spherical, this plus value is in every quadrant of the lens, 360 degree of the lens. So it means that +6 will be at 90 degree because it is spherical. So spherical will in every corner of the lens, right? And at this meridian as well, +6. Now we have cylinder. Cylinder is +2, and what are the axes of the cylinder? The axes of the cylinder are 90 degree, right? So you know very well that there are two principal meridians of the astigmatism or the cylindrical lens. One is the principal meridian number 1 is the power meridian, and second is axis meridian. And the power meridian and the axis meridian are always 90 degree apart. You know very well. So axes are 90 degrees, so it means that if the axis meridian is at 90 degree, power +2 will be at 180 degree, right? So power will be at 180 degree, and this is 180 degree, so +2. Collectively it will be +8. So right now we have +6 at spherical at 90 degree and +8 at 180 degree, right? So now, for example, this is the eye, right? And you have to prescribe base in. Decenter this lens in such a way that it will give you the base in effect, right? So base in is actually representing that. Remember that there are two different types of the deviations, vertical deviations and horizontal deviations, right? If you got the horizontal deviation, this horizontal deviation, you will choose this meridian, this 180 meridian, and the value at 180 meridian is +8. And if you got the vertical deviations, then you will choose this meridian, and at vertical meridian at 90 meridian the value is +6. So base in, right? Just look carefully that the value is base in. So actually the base in is actually representing that the deviations are the horizontal, this horizontal, right? Horizontal mean either it would be base in, or it would be base out, or it will be base in, right? So base in is actually representing the deviation is actually the horizontal. So we know that the deviation is horizontal, so that's why we'll choose this meridian, this 180 meridian. So the value at 180 meridian is +8. So we will put +8 in a formula, and you know very well what is the formula. Formula is P is equal to H cross D, right? So P is prismatic effect and prismatic effect is given, and that is 5, right? And H is decentration. We do not have decentration, so we will write as such. The dioptric value is +8 because we are dealing with the horizontal meridian, and the value at the horizontal meridian is +8, so we will write +8. So let's resolve. H is equal to P over D. P is 5, D is 8, and when we will resolve it, 5 over 8, it will be 0.6 centimeter, right? Remember that in the formula of Prentice rule, the decentration will be always in centimeter, not millimeter, not meter, always in centimeter. You can convert, now you can convert this centimeter into millimeter, right? So 0.6 means 6 millimeter. So we got the decentration, and that is 0.6 centimeter or 6 millimeter, right? And now we will learn that how we can decenter this plus spherical lens, or in which direction, right? We have to know that in which direction we will move this plus spherical lens, right? So let's decenter our plus spherical lens. You know that the deviation is horizontal, base in is actually representing the deviation is horizontal, right? So at horizontal meridian, power is +8, so we have to move the lens. You know very well about the rule of the orthoptics or the squint, that the apex will always towards the deviation, right? So look, base in is actually representing the apex is out, right? Base in mean apex out, right? So apex out mean the deviation is outside. So for example, this is the nose, base in mean apex is out, and if apex is out, and you know very well that apex is always toward deviation, so it means the deviation of the patient will be outward, so it is exo. So we have +8. Let's put the lens. So this is plus lens, so this is plus lens. Right now the plus lens is exactly at the proper appropriate position in the center, but the eye is outward, there is exo, right? We cannot move the eye, but we can move the lens. So this is the black marker is actually representing the eye, which got the exo deviation, and this red lens is actually representing the plus spherical lens, right? So in which direction we will move this plus lens? Remember that I'm giving you the clue. This is very important line. If I move the plus spherical lens, right, inside, the base will go inside. Remember, this is the concept. If I move plus spherical lens outside, the base of the prisms will go outside. If I move the plus spherical lens upward, base will go upward. If I move the plus spherical lens downward, the base will be downward. It means that wherever the plus spherical lens will go, base will go in the same side. Remember this thing, right? And this is the base orientation, right? And now remember that if the deviation is exo, right? If the deviation is exo, you will move the plus spherical lens in the opposite direction. The plus spherical lens will always move in the opposite direction of the deviation. If the deviation is outward, plus spherical lens will move inward to correct that deviation, right? If the deviation is inward, if there is iso deviation, plus spherical lens will move outward. Remember that this is the real concept, right? If the deviation is downward, hypodeviation, plus spherical lens will decenter upward. If the deviation of the eye is hyper, right, the plus spherical lens will move downward, right? It means that the plus spherical lens will always move in the opposite direction of the deviation. So in this case, you can see this is exo deviation. The deviation is of outside, exo. So we will move the lens, we will pick the lens from the center, right, and we will decenter this plus lens in the opposite direction. You know what I said? If the deviation is outside, we will decenter the plus spherical lens inside. So we will pick the lens and move in this direction. And you see, if I move this lens from this position to this position, this apex will be in front of the deviation. And that's what I want. I want apex towards the deviation. How? If I move this lens from this position to this position, right? You see, the apex is right exactly in front of the deviation, right? So this is actually giving the base in effect. Now let's change the statement. For example, you got the same prescription, but the statement is base up, right? 5 prism, base up. Now base up mean, base up or base down mean the deviation is vertical. So if the deviation is vertical, we will pick this meridian of +6, this vertical deviation. So let's put the values in the formula. P is equal to H cross D. H is equal to P over D. P is prismatic effect is 5. Dioptric lens is of +6, and that will be 0.8 centimeter or 8 millimeter. This is the decentration, right? And now base up mean if the base is up, apex is down, and if the apex is down, this is actually representing that the deviation is downward, right? This is hypodeviation. So for example, if this is the eye, the hypodeviation, this is hypodeviation. You see, this is hypodeviation. So to correct this hypodeviation, ophthalmologist or optometrist prescribe +6 with +2 cylinder at 90 degree 5 prism base up, right? So we have to move this whole lens of +6 and +2 cylinder 8 millimeter, and in which direction? Let's learn about it. So for example, this is plus lens, so this will look like this. This is plus spherical lens. Now the deviation is vertical, so I'll make the lens orientation like this. 2 prisms base to base, they are attached base to base. So I have to move this plus spherical lens 8 millimeter or 0.8 centimeter. In which direction? Up or down? Let's learn about it. So you see, the deviation is downward, so apex should be towards the deviation. Apex should be in front of the deviation, right? So for that sake, what do you think? You know very well that if the lens is spherical, I have given you the concept that if the lens is spherical, deviation is downward, then I will move the lens in the opposite direction. The plus spherical lens will always move in the opposite direction. So in opposite direction means if the deviation is hypo, lens will move upward, right? So again, let's make so this is hypodeviation. So now I will, because the deviation is hypo, downward deviation, I will move the lens upward. So I will move the lens upward. I will pick the lens from here and take it here. So you see, this prism will go out of the eye, and this prism will exactly, the apex is exactly in front of the deviation. Apex is always towards the deviation. So this is the principle, this is the rule of the orthoptics, that apex must be towards the deviation. So you see, the apex is towards the deviation, right? So I will move this plus spherical lens, right? Or I will decenter this plus spherical lens 0.8 centimeter or 8 millimeter, and this will give me the effect of base up. So now, for example, you got a prescription card having -6 spherical with -2 cylinder at 90 degree. Now let's make an optical cross. -6 spherical, so it will be everywhere, here and here at base, because spherical correction will be everywhere, in every quadrant, in every meridian, right? So -6 spherical here, -6 spherical here. -2 cylinder is at 90 degree. If axes are at 90 degree, power will be at 180 degree. So at 180 degree, so -6 and -2 will be -8. So at vertical meridian, power is -6. At horizontal meridian, power is -8. For example, you got the card and a note is written that 5 prism diopters base in. Base in is actually representing the deviation is horizontal. So at horizontal meridian, power is 8. So let's put these values in the formula. So your formula is P is equal to H cross D, H is equal to P over D, P is 5, D is 8, 5 over 8 is 0.6 millimeter or 0.6 centimeter actually, and 6 millimeter. So we have got the value of decentration, and now we will got the direction of the decentration. So we have a difference right now, and that is now we do not have any plus spherical lens, we have minus spherical lens, right? So remember, just listen the concept again. For example, if you got the minus spherical lens, if you got the minus lens, right, it means that if you move the minus spherical lens in inside or inward direction, apex will go inside, right? If you move the minus spherical lens outward, apex will go outward. If you move minus spherical lens upward, apex will go upward. If you move minus spherical lens downward, apex will go downward. It means that wherever the minus spherical lens will go, apex will go in the same way. Apex will go in the same fashion. Apex will go in the same direction. Number one. Number two concept is if you are moving the minus spherical lens, for example, if the deviation, if the squint is of in, or you got esotropia or esophoria, you have to move the minus spherical lens in the same direction. Again, if you got the deviation, what deviation? ESO. You will decenter your minus spherical lens in the same direction, in ESO direction, inward direction. If you got the squint of exo, the outward, you will decenter the minus spherical lens outward. If you got the deviation of hyper deviation, you will move or decenter the minus spherical lens in upward direction. If you got the deviation or squint of hypodeviation downward, you will decenter the minus spherical lens downward. This is the concept. So now, for example, base in is actually representing the deviation is horizontal. For example, this is the eye, and base in means apex out. If the apex is out, the deviation is out, right? So it means that the deviation is exo, right? So if the deviation is exo, right, and lens is spherical, minus spherical, right? So if the lens is in center right now, this is minus lens, you know, the two prisms are attached apex to apex, right? And you know the concept, if the deviation is exo, you will move the minus spherical lens in the same direction. And what is our goal? Our goal is the apex must be towards the deviation. And how can we put this apex towards the deviation? By decentering the minus lens outward. If I put the lens of minus spherical from this position to this position, actually I am decentering the lens toward the outer side. So I have given you the concept that if the deviation is exo, outward, simply you have moved the minus spherical lens in the outward direction. So if I put this is nose, the deviation is outward. So for example, if I put this corner of the lens and decentered is towards outward, so apex will be here. Right? So apex is towards the deviation. You see, if apex is towards the deviation, deviation is exo, mean outward. So it means that apex is outward. If apex is outward, base is in. So I am actually moving the lens outward, but it is giving base in effect right now. Right? I hope this is clear. We'll see you in the next videos.